That image AI features are driving significant app downloads, but unmanaged API costs are a critical threat to profitability. The default architecture of proxying every request to a premium cloud service is not scalable. This briefing provides the blueprint for a hybrid agentic system to mitigate these costs. The core architectural flow is routing every request to a premium monolithic cloud API. This approach is simple to implement but operationally inefficient and financially unsustainable. The solution requires a more intelligent, multi-layered system. The solution is a hybrid agentic router. Here is the architectural blueprint. Owning the triage layer. This is your request ingress point. Use a small local model like CLIP to perform an initial classification. The goal is to generate a complexity score. For example, CLIP can classify a request complexity on a 0-1 scale based on prompt length, entity count, and style requirement. A score below 0.4 could be designated simple, while anything above 4.8 is complex. This local check costs fractions of a cent in compute. EWO, the routing agent. This component implements a policy-based decision engine. Based on the triage layer's complexity score and other metadata like user subscription tier, it routes the request. A simplified policy might look like this: AF complexity score 0.40 and route to local stable Diffusion XL. O 0.8 OR user tier per premium tier and route to DALI 3. This prevents unnecessary API calls for simple task semantic caching. This is a critical optimization layer. Before routing, embed the user's prompt into a vector and perform a similarity search against a local vector database like ChromaDB. If a semantically similar prompt with a high cosine similarity score exists, serve the cached result ration entirely. To manage cache freshness, implement a TTL-based invalidation strategy, for instance 24 hours, to balance cost savings against the need for novel content. Hard or not running local models like stable Diffusion XL requires adequate hardware. A reasonable baseline for production performance is a GPU with at least 16 GB of VRAM. Let's walk through a workflow. A user uploads a photo with the prompt, "Make my dog look like a Pixar character." First, the CLIP model in the triage layer assesses the prompt and image, classifying it as a style transfer task with a high complexity score. The routing agent's policy directs this task, which requires high character consistency, to a specialized local model. It selects a fine-tuned IP adapter model running on stable Diffusion XL. This specific IP adapter has been fine-tuned on a curated data set of stylized characters to ensure it maintains the subject's identity while applying the new style. The result is a high-quality, consistent image generated for the cost of local compute. A critical caveat: the router must not be a static keyword-based FLs block. It must be an adaptable system that you can evaluate and retrain. Monitor key performance indicators such as routing accuracy, cost per generation, and cache hit rate. Set a performance threshold, for example, below 95% or average cost per request increases by 15%. It triggers a retraining cycle for the routing model. The most direct starting point is to implement the semantic cache. Use a library like sentence transformers to embed and log all incoming prompts to a vector store. Analyzing the frequency of semantically similar requests provides an immediate data-driven case for this architectural pattern. This is the foundation for building sustainable, scalable AI products. For more architectural deep dives, subscribe. Share your premier AI cost center in the comments.